Hello students and welcome to our lecture on Introduction to Data Science. Our today's topic is data visualization, and we would cover different concepts and methods of visualization in this lecture. So let's begin. So the outline of today's lecture is we would define what visualization is, how not to do it, and how to do static visualization and how to make it interactive. And we would look at different types of visualization both in static and interactive manner. And then we would discuss some visualization tools as well. So let's start with a classic. It's a map. It's a visualization which was developed in 1869, which shows the Napoleon March through Russia. This is the point where he entered Russia from the Poland-Russia border with the width of this band actually shows the size of the army, and as you can see along the way the number of people in the army is reducing, so because of different reasons. And then the black stripe shows actually the return journey, and each point is actually labeled by the area through which they were passing, and then the return journey. And the line below actually shows the temperature along the way when they were going back. So it may well be the best statistical graphic ever drawn in the classic period. It's remember that it was plotted. This visualization was drawn in 1869. It shows 5 variables: the size of the army by the width of the band, location by the labels, the dates on the time scale, the direction. So the direction is shown by whether the strip is gray or black, and the temperature during retreat. So let's move on. Let's see some more examples. There is a very interesting video on Gapminder. So let's watch this video. However, since because of COVID, we have seen a trend, positive correlation between the wealthy countries and the death rate, because the people were living more healthy life, and they had more people with older ages, which were, so that's why they were more affected by the COVID. Okay. So there are some more interesting examples which you can access from these links. So you can watch them or see them in your own time later. So let's continue. So let's start with some types of visualization. So the type of visualization depends on what you want to show. So there are temporal visualization which actually satisfy two conditions. They are linear and they are one-dimensional. So which is actually when you show the trend of data versus time. Then there is a hierarchical visualization, which are those that order groups within larger groups. And then there is network data visualization, then multi-dimensional data visualization, and geospatial or spatial data visualization, which is more related to real life physical locations, geographical locations, overlaying familiar maps with different data points. So let's see a bit of them in details. So temporal visualization is what you normally see and use. For example, your scatter plots, your line plots, your time series sequences, etc. These are the types of visualization that you usually plot in matplot using matplotlib or plotly in Python. And they're the most simplistic visualization. Most of the time people would use Microsoft Excel or PowerPoint to draw these visualizations. And there are types of static visualization. Then we have hierarchical visualization, which actually forms a tree or hierarchy, and they're best suited if we are looking to display clusters of information, especially if they flow from a single origin point. So then, so we have tree diagrams here, we have ring charts here, and we have sunburst burst diagram here. Then we have geospatial visualization, which actually is the type of visualization which are commonly used to display sales or acquisition over time. So, for example, if during war, if a country is acquiring some territories, or if a disease is spreading through different regions in a country or the world, and they can be shown using geospatial visualization. There are flow maps, which shows movements of objects between geographical points. Then there is density maps, cartograms, and heat maps. So there, here you can see a heat map, and here you can see a population density map of Pakistan. Let's see some anti-examples of visualization, are the examples where we show how not to use or visualization, or which are the wrong way to show visualization. And remember, visualization can be a very dangerous tool for propaganda, for political discourse, and so there is a website which is called WTFwiz.net, which actually keeps a record of such types of visualizations. Here you can see an example where a visualization could be used to educate the public. It shows the Obamacare enrollment from between March 27 and March 31st, and if you look carefully, the numbers are not much different, but the graph is plotted in such a way that it shows a significant difference, so which is wrong. And on a first glance, or if you are not careful enough, you can be easily fooled by this type of visualization. Another interesting example, there is 7 billion total population, more or less, in the world, and here is a pie chart which shows the percentage of people that uses internet or mobile internet. And as you can see, it's not a clear, it does not give a clear picture, because it doesn't show the percentage of people who do not have access to the internet, which is basically 1/3 of the total population. But this visualization somehow it seems like there are 33.3% of the world population, not the internet users, which uses mobile internet, and 66.7% of the world population which uses the internet. And although these two subsets should not be exclusive. So this is another example of a wrong visualization. Another one, here is another pie chart, and if you add all the numbers, they are more than 100%, which is again wrong. Some other one, another example. This is another example, a more recent examples, which shows the coronavirus confirmed cases. And if you see here, the numbers are not as different as they are shown by the size of the bars. And so this visualization could be used to show that that there is a decline, but although this number 4049 is much larger than 3207. Okay, so that's not how to, so that's how not to do it. So let's talk about how to do it well. So we need to have some principles, some concepts, so we can base our visualizations on those principles. And then there are some best practices for static visualizations, and then there are emerging principles and tools for interactive visualizations. And remember, interactive visualization are those where you can hover, for example, your mouse or your finger, or those visualization, so they would give you more information which is not clear at the first glance. Okay, let's see some definitions. The OED.com defines visualization as the action or fact of visualizing, the power or process of forming a mental picture or vision of something which is not actually present to the sight. So thus a picture is formed. Some more definitions. McCormick defines visualization as transformation of the symbolic into the geometric. Burton defines visualization as finding the artificial memory that best supports our natural means of perception. So our natural means of perceptions, so for example, we can perceive huge amount of data through our eyes by means of visualization. Then Card et al. Defines visualization as the use of computer generated interactive visual representation of data to amplify cognition or to amplify understanding. Okay, the uses for data visualization. Visualization supports reasoning about information. In turn, it's used for analysis. For example, these analysis could be finding relationships between different factors, discover a structure, quantifying values and influences, and it should be part of a query analyze cycle. Uh, uh, B is to inform and persuade others. So visualization not only can be used as a means of analysis, but also as a mean of communication. So, for example, if you have to show your results, your data, or your understanding or your analysis to a third person, then you can use visualization for that. So, in that manner, visualization should capture attention, it should engage, it should tell a story visually, and it should focus on certain aspects and omit others. Okay, visualization is a tool for data presentation, and it can be shown by a designer reader data trinity. So we have at the vertices we have a reader, we have a data, and we have a designer. So the data is used by the designer to create a visual art, and that visual art can be used to persuade a reader, and the reader information is encapsulated inside a data. uh, okay some more use of data visualization. A big use of data visualization is to create interesting pictures, eye-catching pictures, so they can be used on magazine covers. um, there is a very popular visualization competition annually being held, which is called Vizi's Visualization Challenge, and the competition is mostly about creating visualization which can explain, which can interpret, which can communicate data clearly, but also interestingly and engagingly. Okay, let's see some cases for ugly visualizations. Okay, so people usually instinctively gravitate to attractive visualizations, and they have better chance of getting on the cover of a journal. But this may conflict with the goal of visualization. For example, the goal of visualization is not always that they should look pretty. It should be able to available for rapid exploration, and should focus on most important details, and they should be easy and fast to develop and customize. So for example, if you see a traditional business information graphics which is represented by bar charts, it doesn't look nice, it doesn't look pretty, but it's more informative, and so it's a good, it's still ugly but a good visualization. And we can then argue about the tools of visualization, for example, to use whether to use PowerPoint or Keynote or InDesign. So there are lots of different ways and methods and concepts and comparison that visualizations can provide. Let's see another example. Here we have some performance representation of batteries and engines through visualizations, and at the first glance it looks very complicated, but if you see, it has some more information and interactiveness that it can be provided. Ugliness does correlate with hard to interpret, but they're not the same thing. So sometimes we can have to use some ugliness, but still have a good visualization. Okay, so where does the visualization fit in the data science workflow? So it can have different. It can be put. It can be plugged in at different parts of points at different stages of the data science workflow. For example, this is where the data input is coming from, digging around in the data. Then we have a hypothesis model. Then we have a large scale exploitation. So at different stages, visualization can be used to evaluate and interpret. For example, it can be evaluate the original data, the raw data. Then it can be used to evaluate the model that is used for hypothesis, and it can be used to evaluate the end product, and most importantly interpret the end product. Okay, let's move on towards some interactive visualization. So visualization usually aren't an end in themselves, but part of a query interpret cycle. So they can be, so they should be able to interpret something, and you should be able to query information from a visualization. So that's interactivity can be used to speed up the query interpret cycle for that purpose. There are some examples. Baby names Voyager. You can go to this website and explore it a bit. It would help you understand the concepts and the benefit of visualization a bit more. There is another project, Many Eyes, which is abandoned, discarded now. Okay. Okay, up till now we have considered visualization and when to do it and how not to do it, how to do static visualization and making it interactive. Okay, so when you are using visualization, it's very important to first choose which types of visualization do we need. So the basic idea behind choosing visualization is what would you like to show. So for example, if you want to show a distribution, then you can use histograms, you can use line histograms, scatter plots, or 3D area charts. On the other hand, if you want to use visualization to show relationships between different variables, then for that you can use bubble chart or scatter chart. So you can look at this chart for different types of visualization and when and which visualization to use. Juice Analytics provides a good tool. It's a very good tool to choose and to select the most optimal and the best visualization tool or chart. So here you can just choose by clicking the type of data or the purpose of the visualization, and it would give you a list of different visualizations or charts. Design considerations is very important during visualization. Design consideration means the colors in visualization, the size of different parts, the fonts that you use, the labeling, etc. So in tables and charts, the purpose should be to reduce the chart junk or table junk, which means we should have more data to ink ratio, so less to represent more, and then to use lessons from perception, which is by limiting the number of objects displayed at once, so that like at one glance the visualization doesn't look too complex, and we should interpret by just looking at the visualization. Then the typography, which is capitalization, which font to use, and for that usually the way to follow is what the company uses. Then the color schemes and the six Gestalt psychology principles, which is for group of objects to use proximity, similarity, enclosure, and connection, and for visual representation to use closure and continuity. Okay, let's see some examples designs for the charts. These examples are taken from Tim Bray. So here we can see a bar charts which represents some percentages of some population, for example, for different months, and you can see there is a grid on this chart. If we use the same chart without the grid, it doesn't make a big difference, but now the perception is lost, because with the grid it's more easy to perceive different points or different objects in this visualization. Now there is another example of the same chart but without color. another one without the boundary, another one without the boundary and the color and the grid, but now there are lines on top of the charts that represents different percentage points. Okay, so for design considerations for color, by default, you can use your organization's palette. Choose colors based on the information you want to convey, whether it's sequential, whether it's diverging or categorical, and then we can use online resources to discover and record our color schemes. Such online resources are Color Brewer, Cooler, and Color Lovers. Here is a color scheme which use sequential, where the same color type of this with the same hue but with different saturation is ordered from low to high, so it can be represented, be used to represent different amounts or different ranges of values. Then we have a diverging, where two sequential schemes extended out from a critical midpoint value. So it's start from a dark blue till goes to a very light gray, and then it again starts to increase in saturation to make it a dark brown. Then we have categorical, where for each category we use completely different and contrasting color. Here is a tool where we can pick a color from a color scheme. Some more examples. Okay, next we go on to discuss some visualization tools. There are two types of visualization tools, some the open source ones and the proprietary ones. So for example, till now we have used Matplotlib in our experiments in labs, and in some experiments Plotly. They are both open source libraries of which can be used in Python. Then we have Power BI, which is a Microsoft proprietary tool. Then we have Google Analytics, and then we have Tableau. So Tableau specifically is a very good tool, and it's in very high demand nowadays in market. It's a market leading choice for modern business intelligence. It is an analytics platform that makes it easier for people to explore and manage data. It's in high demand. Most data scientist jobs require experience in Tableau. So it's very recommended that you learn these. The students of data science should learn Tableau specifically. It's very easy to learn, and for the purpose of learning, Tableau actually provides a free 1 year free license for full version to students. So I would recommend that you sign up for this tool, and we would also try to have a lab on some uses, some experiments with this tool if the time permits. So that's about visualization. Thank you very much for listening to this lecture, and good luck.